Hey, it's Mr. Burkhart. I am going to make a video on how to do the lab for this week, the second law lab. So the first thing I'm going to do is I'm going to use my camera over here, and I might want to use my calculator. So I don't know if we can actually see that. Let's see if we can get a light on. Oh, that's not good. All right, I don't know if that's going to work or not, but I'll put that right there for calculating. I guess I could just use a computer. All right, so land on my home page. If you click on modules, it'll be on the modules page. And we're going to scroll down to week 7. We're going to click on assignment 3, second law lab. This will pop open. We're going to open up our simulation. This will pop open. Going back over here, we're going to click on the link to the worksheet, and it's going to open up our worksheet in a new. So here's our CAMI paper that we're going to use to write on to submit. Right? I have a save button. You have a submit button. I have an extra piece of CAMI graph paper open just so I can show some work later. It's not required for you to do it. Here's another link to the simulation in case that doesn't work. Okay, well, you'll have to get to so this link doesn't work. Make sure you access the lab here. So we're going to click begin. So what we have here, this is a sensor that can measure how much force you use to pull a puck, which is on like an air hockey table, right? So it's floating on the table, and we can change the mass of the puck, and we can change the force strength here. So what we are called out to do is do a couple of different things. The first thing we're going to do is keep the force the same and change the mass and find the acceleration as that happens. Okay, so we want to use 500 grams and 1 Newton. We go over here, we change this, lower, 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 500 grams. Now we want our force sensor to be at 1 Newton. So it might not go to exactly 1 Newton because it's kind of touchy. Oh, I did. I got it on 1 Newton. That's luck. If you can't quickly get it right on 1 Newton, then using 1.2 or 0.8 or 1.1 or 0.9 is fine. Just make sure it's the same every time for this trial. So we don't want to change this anymore. We want to just keep the hockey puck. We're going to make the hockey puck different every time. So we're going to pull this. The nice thing about virtual simulations is, so we're pulling, boo! So what happened here? Well, we pulled it, and the equipment we had, if we were in real life, we would have equipment that would do this. It makes a position graph, and it makes a velocity graph. So the position graph is interesting to look at, but not very useful. It's a velocity graph we're going to use for our data table over here. We have the mass already entered, we have the force entered, now we need the acceleration. So this is the tricky, tough part, is we need to get the acceleration from this velocity graph. So what I'm going to do is I'm going to go ahead and snip this and throw this into a CAMI so that I can write on it. Let me make sure I got all the information I need here. All right, so did not try this ahead of time. Copy, paste, go to my grid. Here, this is extra. Come on. Just sure save it. Let me, okay. Let's make it a little bigger so we can see what the heck we're doing here. Stop it. There we go. And we have a random green line, which I guess I can erase. Oh, shoot. Okay. Erased everything. Okay. Let's make this bigger. So finding the slope can be a little tricky. So what we want to do is just find the rise over the run for 1 second. So here we are at 1.2 seconds. So right here, we're at 1.2 seconds. So to go 1 second later, we would be at 2.2 seconds right here. So what we're trying to do is simplify finding the slope. The slope is the acceleration. Slope is the acceleration. How steep the line is. Okay? So I know that the run is 1 second. It starts here and ends here, right? So we're going to be dividing by 1. So what I'm suggesting is you always make the run 1 second so that you're dividing by 1. So all you have to do is be able to count. We have to be able to count from 0 to however high this is. So this is 0.5, 1, 5. So how much is each one? 1.5, 1.6, 1.7, 1.8, 1.9. Yeah, that works. Every one is 0.1. So this line here is at 1.9. So it rises up 1.9 over 1 second. That's the answer. So I go back over here, and I want this to look nice. I'm going to go 1.9. This is going to probably take a while to do this lab. All right, now I go back to my lab. Oops. And now I reset, and I increase the mass to the next mass. I don't remember how much it is. 1250. All right, so let's jump it up to 1250, and let's do it over. Pull. Woo! It pulls. And then we go down here, and look, we have another graph. So I'm going to snip this one. All right, you don't have to do this part. You could just do it right on the, right on the, you could just get the information right off of the simulation. I'm doing this as a courtesy to my friends in the physics world. All right, so we can just drop this right on here and grab the grabbing tool, and that's not going to work. I don't know that it lets me do another page. That's too much time. Maybe it'll just let me do another grid. That's going to take too much time. Okay, so I'm going to go back over here with my eraser and go erase, erase, erase. Go away. Ollie, go away. You too. No, not you. Okay, let's put it back on there. Grab it. So you can see I can't do too many of these as an example. Otherwise, this video is going to be too long. Right, again, I'm going to pick a 1 second interval of time. So here is 2 seconds right here. And then I go to 3 seconds right here. So I'm going to be dividing by 1 because the run is 1 second. So I just have to be able to count from here to here. So this is at about 0.1, and this is at about 0.9, right? So we count from 0.1 to 0.9. 1, 2, 3, 4, 5, 6, 7, 8. 8 of them, and each one is with 0.1, so this is 0.8. 0.8. So that's the answer. So we go back over here to our paper, and we grab our text box, and we go 0.8. Oops, text box didn't work. Really? I feel your pain, kids. Right. And you just keep repeating that process. Then we go over here, and we go whoop, up, reset, 1500, push the button. All right, so once you get going, it's easier. Always make sure you pick the bottom graph with a straight line, not the top graph with a curvy line. That one doesn't work. And then let's not do it with Cami this time. We're going to go from 1 second to 2 seconds. So here at 1 second, I am at 0.2. And at 2 seconds, I am at 0.9. So that's 0.7. So we put in 0.7 right here. 0.7. And so on and so forth. So then we're going to do the lab over again. This time, we're going to hold the mass. So you're going to go ahead and do it again for 2,500 and 3,000. And then we're going to go over here, and we're going to keep this steady at 1,500, and we're going to change the force. So we already have the 1 Newton one, 0.7, right? That piece of data just carries over from the other lab. And now I want to know, how does the acceleration change if I double the force and keep the mass the same? So I go over here, Now let's try to get the force at 2, or as close as possible to 2, without spending a tremendous amount of time. Well, that was lucky. All right, so here we go. Now the force is on 2. Shoop! All right, and now we do our thing again, skip the first graph. I'm at 1 second is at 0, and 2 seconds is at, right here, that's 1.3. So I put this in here, text box, 1.3. Then I go to 3 seconds, and whoop, 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 reset. Let's go to 3 newtons, 3 newtons, perfect, start, pull, scroll down. All right, at 1 second, I'm at 0, and at 2 seconds, I am a little bit above 2, not quite. So each one, now the scale is changing. Now each one is 0.2, right? Well, that's 0.5. No, I'm lying. Each one is still 0.1. All right, so it's kind of in between 2.1 and 2.0. So I'm going to write 2.05 right here. 2.05. Now we go to 4 newtons. Scroll, scroll, scroll. Reset. Oh, gonna have to go with 3.9. I'm gonna spend all day messing around with it to get it at 4. And now, so I'm at 2, so I want a 1 second interval. So I'm gonna start here at 2 seconds. This is 1.6. And at 3 seconds, I'm at 4.3. 4.3, 1.6. This is where the calculator comes in. 4.3 minus 1.6. You got to turn it on first. Put it clear. 4.3 minus 1.6. That's 2.7. So I go over here. I go clickety click. 2.7. It wasn't exactly 4 newtons, so there's going to be some error, but that is to be expected in science. All right. Now we reset. 5 newtons. Yay. Exactly 5 newtons. Pull. Shoop. And we go down here. So this one's a little trickier. We can use the line still to do 1 second. So I'm going to go here, which is, I'm going to call this about 0.7. So I'm at 0.7 here. And then at 2 seconds, my line, so it's okay not to use the data. I can just use the line. My line is at, let's call it 4 seconds. So 4 minus 0.7. 4 minus 0.7 equals 3.3. All right, 3.3. 3.3. Remember, we didn't, 3.3. So I didn't finish this part of the lab for you. You're going to have to finish that part yourself. If you'd like your data to be all lined up and nice and neat, you're going to have to grab your little boxes and line them up. So there are questions to answer. I think you can answer the questions. And then we're going to graph our data. So we have to go down here and we have to graph force and acceleration. So force goes on the y-axis and acceleration goes on the x-axis. So we're graphing this data, we're graphing this data right here. This is the y-axis, this is the x-axis. All right, so we're going to go 1 and 0.7. So here's 1, and here's 0.7 right here. There's a data point. What's the next one? 2 and 1.3. So we're going to go 2, 1.3 is right here. And then we had 3 and 205. Whoops. One and 0.7. 2. Okay, I think I did something wrong. 2 is 1.3. Okay, I did something right. 3 is 2.05. Okay, 3. 2.05 is about right here. And 4, 2.7. 4 is 2.7, which is here. And 5 was 3.3. 5 is here. 3.3 about right here. So you can see we should get a line. It makes a nice line, actually. Right? And is 0, 4, 0 acceleration? Sure it is. So we can draw a line that goes to our data. Should have started at 0. You can have a nice line. And now you can find the slope of this line, right? Taking 2 points, maybe from 1 to 2, so that we're dividing by 0 again. So here's 1, and here's 2, right? And now what's the rise? The run is divided by 1, and the rise would be, you have to count from here to here. But you should do your own, right? And then there's more questions to answer. All right, that was a pretty long video. Thank you for coming to my TED Talk. I hope that helped.